This is Stephanie from statisticshowto.com, and in this video I'll show you how to decide if a test is a one-tailed test or a two-tailed test. I'm going to show you a few sample questions. The first one is: a government official claims the dropout rate for local schools is 25%. We're given some figures, but what we're interested in is this statement. Right here, the claim is that the dropout rate is 25%. What this is saying is it's equal to 25%. So our mean in this question would be 25%. That's our mean mu. If we're going to reject the government official's claim, all we have to do is prove that the mean is greater than 25%, somewhere over here, or if it's less than 25%, that would also mean we can reject his claim. And as you can see, I've shaded in two tails. This would be a two-tailed test. What you're looking for is any word that says is, or is equal to, or is the same as. If you see any wording like that, it's going to be a two-tailed test. Let's look at an example of a one-tailed test. In this next question, we're saying that the dropout rate is less than 25%. If you see any wording like less than, smaller than, this is going to be a one-tailed test. Why? Well, the government official says the dropout rate for local schools is less than 25%. I'm going to put that 25% in the middle. It doesn't really matter where you put the 25%. And here's why. His claim is that the dropout rate is less than 25%. So it's going to be this way on the number line. It's going to be this area here. It's less than 25%. This is a one-tailed test because of the words less than, and we're only looking in one direction. This would also hold true if you had the words greater than or more than. This time we'd be looking in the opposite direction. So as long as it's a one-way claim in the wording, you're always going to be looking at a one-tailed test. And what about if you're not given any wording? What if you just are trying to decide what test you need to do, a one-tailed or a two-tailed? Let's say you're testing a new drug. I will call this drug X. And you want to know whether it should be brought to market. This drug happens to be cheaper than something else already on the market. Well, let's say this area right here represents the effectiveness of the drug already on the market. I'll call this drug A. This area over here, this tail, would represent the area that it's more effective than drug A. And this area would represent that drug X is less effective. Now you could run a two-tailed test and figure out if drug X is more effective or less effective, but as soon as this is cheaper and you want to bring it to market, then really you're only interested in this area here. As long as drug X doesn't fall into the less effective region, then you can bring it to market because it's cheaper. You don't really care if it's more effective, you just want to make sure that it's not less effective than the existing drug. Where you could run into problems is if you choose the wrong tail. Like if you were testing this drug and you decided, well, if it's more effective than drug A, I should just bring it to market. So let's say you just tested this area here for more effective. You just run a one-tailed test here and you didn't take into account this area. Well, there may be some circumstances where the drug is more effective, but if you don't run a test for this tail, then you could run into the problem that in some circumstances the drug is less effective. This can get pretty confusing. Basically, you're going to choose a one-tailed test as long as you're sure there aren't any ethical reasons why you shouldn't. If in doubt, always run a two-tail. So then the question becomes, well, if we're in doubt, always run a two-tailed test, then why would we ever want to run a one-tailed test? The answer to that question has to do with alpha levels, which I will discuss in a later video. But for now, what you should realize about alpha levels is this area is our alpha level. Let's say this is 5%. Our alpha is 5%. If you run this one-tailed test, there's a pretty large rejection region. Compare that to if you run a two-tailed test, you have to split this 5% into 2. So on this side we would have 2.5%, and on this side we would have 2.5%. So our tail would be much smaller. There's our 2.5% tails. So the rejection region on either side becomes a lot smaller. Ideally, you'd want to run a one-tailed test if you can, because you get a larger rejection region. Thanks for checking in. See you in the next video.